bunch of OpenGL specific stuff, like I enable the texture 2D capability of OpenGL, I enable the depth test, and I test for what extensions are available on the GPU. Now this is another thing that I use for cross-platform compatibility. I want to make sure that the frame buffer extension is available on the GPU, and if it's not available on the GPU as an alternative, I use the copy text image. There's a command that I use to copy the image that's on the screen to a texture on the GPU instead of using a frame buffer. But if frame buffers are available, they're used by default. And in addition to that, so here's where I check if the FBs are supported, then I just use the frame buffer objects, and otherwise I have a bunch of alternate methods and stuff in here. So this is what I use as the alternative. So now, here's what has to be implemented in order for this to work. GL renderer inherits from the renderer class. So everything that's in, it has to override a bunch of members. So set render target, which if you're familiar with XNA, this syntax was actually, I derived it from the way XNA and DirectX works. So set render target internally uses frame buffer in OpenGL, but it behaves the same way as an XNA or DirectX context would. So, and this is completely asynchronous, and it supports multi-threading, so it's entirely thread safe if you look at the example here. So back to the main example, I create a thread here, so there's a render thread here, but then controls immediately passed back to this code down here. So I set the camera position on this thread. I create the basic shader. When I tell it to create the basic shader object, it returns a handle to a shader, and then I tell it to draw that shader. And these operations are all executed in the order that they're passed in. So one area where you could have problems potentially would be if you have multiple threads generating these commands simultaneously, then the first thread to pass in a command would be the command that would be executed. So multi-threading can be used to set positions and to load textures asynchronously, but you still need to practice good practices that you would normally use when you're using multi-threading within a GUI application. But regardless of how multi-threading is used in this context, it will most likely not hang the GUI of the application because of the way that the queue is implemented. And then down here, after I create the shader object, I draw it, which essentially applies it as the current shader program that's being ran. Now, currently the only type of shader that is implemented is a basic shader, which supports basic lighting in both HLSL and GLSL, and in XNA it uses the basic effect class. If anyone's familiar with XNA, the effect that I'm using is similar to the basic effect class in XNA. So this here is a system drawing that bitmap. Now, can anyone in here tell me what would be wrong with using a system drawing that bitmap in a cross-platform application, in theory?
Resolutions.
What?
Your resolutions. How, if that bitmap is too big for a smaller device, would it scale?
Well, the problem I was thinking of in addition to that would be, well, what the main problem would be is system.drawing that bitmap is not available on Windows Phone, and it's not available in Linux because it doesn't support GDA+. However, the advantage to using a managed language and an easily extensible language like C# means that a system drawing that bitmap class can easily be implemented on the platform that you're using in a cross-platform manner that uses whatever rendering technologies the platform it's running uses. So
that's not necessarily exclusive to a managed language, because you could implement different libraries for rendering graphics on different platforms, so
although it's easier to do in a managed language.
that is the more important question.
And also, when using the .NET framework, a lot of the binary files that are generated as a result are compatible between platforms. For example, if I compile this application on Windows, I can actually use the same binary that I'm using on Windows in Linux, which I'll demo when I'm done showing this code here. So, now before I get into any more details of this code, since it's a bit more complex than a basic example, I'll go to a simple triangle example. So we'll create a new project in Visual Studio, and we'll use .NET 2.0 to ensure that it's compatible with the mono platforms. So we'll call this application Simple Triangle. And then we'll add a reference to the required libraries, so to 3D API, DirectXlib, and to the GL library, which is not in the recent list, so I will browse for that and add that manually. So now I will import the DirectXlib, the 3D API, and the GL library. Then I'll do this statically instead of creating, I could create an instance of a class that would, but I'll create a static renderer, call it renderer. I'll try to initialize a DirectX context. If that fails, create an OpenGL context. Then create a basic shader object. Apply the shader. Now import a reference to system.running. And then create a texture 2D, which will upload it to the GPU. And call it texture equals render that create texture from bitmap. And then apply the texture. And then set the camera position to 5 or -5, I think. So, and then let's actually upload the vertices. So, create a list of vector 3Ds. And is everyone here familiar with the 3D coordinate, the general 3D coordinate system in three-dimensional programming, or do they need an explanation as to how this works?
Z is in and out, X and Y. X is horizontal, Y is vertical.
So now add the texture coordinates. Oops. And the texture coordinates basically tell the GPU how to map the texture across the three-dimensional surface of whatever object you're drawing. And then the last thing I need are the normals, which are used for lighting. And I'll just set all of them to 1. So. And then the next step is to actually upload them to the GPU. So I pass in the vertices, the texture coordinates, and the normals. And then that should render a triangle, but one thing I forgot was to put in the actual the picture and the shader, so I will copy and paste that from my existing sample. And I called this GL-test-stat because when I started thinking about this, I originally planned on using OpenGL's domain method of rendering, but I realized that not all platforms such as Windows Phone support OpenGL, so I made it more cross-platform so it can use either DirectX or OpenGL or even XNA. And the good thing about the way that I made this library is it's easily extensible because most of it is highly abstracted, so. Copy that, and if I'm wrong about the -5, then nothing will render, but otherwise it would be a +5, so. And DirectX sometimes does that on this computer. Let's see. Oops.
Is it your normals? I don't think you declared a size on it. So when you did a count loop on it, probably
Oh.
didn't have a count.
Text
So.
boards.
Oh, whoops, I should have had this less than 3 instead of, because there are no normals, whoops. First time doing this.
It's okay. I saw
Ah, there,
I
triangle
saw it there,
cross.
but I was confused with all the other codes, so I didn't know if.
So, what were you confused about?
So I don't really know.
So
anything
this
about-
is the triangle here.
Yeah. So if you go back to the code, and if I'm the only one that's confused.
Well,
so, yeah.
I don't want anyone to be confused about this,
So-
so.
You're creating those 3 vertices, and those are just the points of the triangle, right?
Yeah.
Is that what that first part is? And then the texture coordinates, that's the one part I don't even understand what that.
So, the texture coordinates should mirror the way, it describes how you wrap it around the object. Like, let's say you have a triangle, this is 0.00, this is 0.01, this is 0.11. So, you want to tell the system where the top of the triangle is. You can, like for example, you tell it that it's 0, so you simply mirror what the coordinates are that you want to draw
Okay,
the
so
texture
mapping
on,
the texture
basically.
onto the triangle.
Yeah.
And the fact that.
And that's using something called a sampler,
Okay,
which
so the facts
is,
are all the same, it's just the
and-
whole texture on the triangle as opposed to.
and the,
strip. Okay.
yeah, and the sampler is implemented within the shader, which
And then the normals.
here's the shader that I'm using for DirectX.
And
So,
then the what was the normals?
is everyone here familiar with shader programming? Or,
No.
There's the intros.
I know it's kind of considered a dark art.
Your idea was to take cross-platform, so let's talk more about the levels of abstraction and what features you wanted to implement such that you could then, of course, when you abstracted, you have to then implement those things on the various platforms.
Yeah.
So let's see, can you explain what features you wanted and such?
So, as I was,
Can I figure out what my normals?
Go for it.
was? And then I actually had the same question as you, and in this set of code we're looking at, which of the things were code that you put that layer that it was abstracted,
Right.
and which ones were like
all of
system-
this is
That's-
all of this is completely abstract, meaning if I reboot into Linux, do you want any more explanation about this code, or should I?
Yes, it does.
Yeah, the normals.
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 Okay, so the
If you want to slow
normals,
down your timing, your talk, we'll skip over it.
so the normals are 3D stuff that's used for lighting, and normals are usually they're not something you generally generate yourself. Usually they're generated with a tool such as Blender, and this library can in fact import Blender models, which, would anyone care for an example of that, or do they want me?
No, let's
Oh,
let's keep going on what's going
Okay,
here.
so, but normals would usually be generated by some kind of 3D modeling tool, so.
So like, I think to your question, that class they're called shader. Is that like an abstracted class from the library
Yeah.
you created?
The
And then
every,
Even like bitmap, is that, or is that in
Yeah.